Hello friends, welcome to Shiksharthi, and today's topic is Logarithms Part 3. And what are we going to learn? And what we learned till now, if I revise once again, on video 1, we have discussed the basic rules of logarithms, types of logarithms, and the significance of using logarithms. Second video, we have solved some questions on rules of logarithms. We have not gone to the application part. We just used rules and we got some questions solved. Now in this part 3, we'll see the application part of logarithms. But for that, we need to know a little bit of basics. Now what is the significance of base? If you remember, there are two types of logarithms. Natural logarithms with base e and common logarithms with base 10. You remember? Right. So if I don't have any base along with the logarithm, by default it is going to be common logarithms. That means base 10. Now why and how these things will work and how this will work is important. I want you to always remember two values in logarithms. Log 2, that is 0.3010, and log 3 base 10 is 0.4771. Both are common logarithms, and look at them. These are nothing but the values of log 2 base 10 and log 3 base 10. If you observe, when I write the value, this have two parts in the value. This is integral part of the value and this is decimal part of the value, right? So value will have two parts. This integral part is known as characteristic. In logarithms, it is called as characteristic, and the decimal part is known as mantissa. Now, there is a significance of characteristic. This will play one important role in logarithms. Now, how the characteristic value is defined, why I got 0 here, and will it be 0 every time is a point. Now, please observe, when I say log 23 base 10, this is going to be 1 point some mantissa value. Similarly, when I say log 234 base 10, this is going to be 2 point some mantissa value. Mantissa value we cannot get directly, that we need to always, by using logarithm table, we need to get those values here. Okay, so let us see some more examples. And here, when I say log 23456 base 10, this is going to be 4 point some mantissa value. Now, how I am declaring this characteristic value? How I declare? Now, if you observe, what is the base, my friend? Base is 10. Now, can I say 23 lies between 10 power 1 and 10 power 2 or not? 10 power 1 is 10, 10 power 2 is how much? 100. So, 23 lies between 10 and 100, correct? So, the smaller value is the characteristic value. You can see 1 is the characteristic value here. Similarly, if I take 234, this lies between 10 square 100 and 10 cube 1000. So smaller power is the characteristic value. So power 2 is the characteristic value. See here, power 2 is the characteristic value. Similarly, when I write this number, it is 23456 and base going to be between 10 power 4 and 10 power 5. So 4 is going to be the characteristic value. Now from these three examples, we can make one more point as a note point here, which is very easy to remember, very important note point here. If you observe, when I have 2 digits, characteristic value is 1. When I have 3 digits, characteristic value is 2. When I have 5 digits, characteristic value is 4. So how the characteristic value can be remembered here in common logarithms? Please remember, this is applicable only for common logarithms. The characteristic value will be 1 short of the number of digits. How many digits we have here? 5. And this is 1 short of the number of digits. Correct? So here you see how many digits we have here? 2. And the characteristic value is 1. And how many digits are here? 3, and the characteristic value is 2. So what I can say, the characteristic value is going to be 1 short of the number of digits. Number of digits are 3, so this will be 2. Number of digits are 5, this is going to be 4. And how this point can be helpful to solve some questions. So let's take some example questions, all of you. So this first question is 20 to the power of 40. Say, I don't apply logarithm directly. Let us take like this. Question is, find the number of digits. Find the number of digits in 2 power 40. That means if you find the value of 2 power 40, imagine 20 to the power of 40. What is 20 power 40? 20 power 1 is how much, friends? 20. 20 power 2 is how much? 400. 20 power 3 is how much? 8000. 20 power 4 is how much? 16. That is 1,60,000, and so on it goes like that. So number of digits are increasing. You see, number of digits are increasing. At 4 as a power, this has got number of digits around 6. I want to know 2 power 40. Imagine 2 power 40 is a huge number. I want to know how many digits will come. Here 2 digits, here 3 digits, here 4 digits, and here something like 6 digits we got. So 2 power 40 will have how many digits? Will have how many digits is the question. To find out that, I'll apply log. You know, log will minimize the effect of powers. Though the power is 40, 100, 200, 300, can be any power given to you, it will have a minimum effect now on the value. Now let us get this, all of you. My next step, you know, if I have log m to the power of p, it is p log m. Am I right? So this power will go in front of it. So it is 40 log 20 is what I get. Now further, 40 into log 20 can be written as log 2 into 10. Fair enough? And then this will be 40 into log 2 plus log 10. And we all know by default it is base 10 and base 10. Log 10 base 10 is how much? 1. And what is log 2 value? I just gave you log 2 value here. 40 into 0.3010 plus 1. And finally, this is 40 into 1.3010. And when I multiply with 40, what will happen? What will happen? If I multiply with 40, what will happen? This will be 402.1 if I multiply with 4, right? And then into, if I take a point here, that is point, because of the 0, this will move here. So it is 12.04 as a value I get. Let me recheck once again. I think I am going somewhere wrong. So let me recheck once again. What is going to be the value here? So this is plus 1, I just multiplied, and because of 0, this is 13.01, and into 4 will make it 52.04. This is actual value. I'm sorry, beg your pardon. This is a value. Now what I got, my friend, here the value is 52.04. What is the characteristic value? 52, which is one short of the number of digits. Remember, characteristic value is 52, one short of the number of digits. So number of digits have to be how much? 53. So when you get the value of 20 to the power of 40, it is going to be 53 digit number. It's a huge 53 digit number is going to come. So before I find the value, or without finding the value, if I wish to know how many digits are going to come for a number, what is the size of the number, then logarithms can be useful. See, the effect of power is negligible almost. Finally, I'm multiplying with 40, I'm getting something out of it. Okay? Let us have quick example, one more here. Say, for example, same question, number of digits is the same question, and my question is to find 36 to the power of 100. 36 power 1 is 36, 36 power 2 is 1296. Huge numbers, right? So we need to know. So apply logarithm, friends. 36 to the power of 100 here. This is going to be 100 log 36. We all know 36 can be taken as 2 square into 3 square. That is 4 into 9, 36. And then 100 into log 2 square into 3 square is what I do. Fair enough? And then 100 into log 2 square plus log 3 square. And this is 100 into 2 log 2 plus 2 log 3 is what you get. And this is 100 into 2 into 0.3010 plus 2 into, again 2 into 0.4771 is what you get. Okay? So let's get the value here. This is going to be 100 into, overall 100 into, if I multiply by 2, this will be 0.602 plus 20 plus, if I multiply by 2, this is 2, 14, 1 carry, 15, 1 carry, and 9, 0 point something change. And then 20 and 42 is 62, 95 and 60 will be 155, so 55, 1 point will be the value, and then multiplying with 100. If you multiply with 100, the final answer will be 155.62 is my final answer. Fair? So what is the characteristic value I got? 155. So this is equivalent to 155.62. Characteristic value is 155, which is one short of the number of digits. So it will have 156 digits is the final answer for me. So based on this, you can see 36 to the power of 100 is supposed to be a huge number with 156 digits number. So huge. So this is the application part of the logarithms. How do we apply the logarithms and all that thing? Now let us go for some part of the another part of the discussion here. As I said, log 2 base 10 is going to be 0.3010, and what can be log 0.2 base 10 then? Okay, so let us prove this. This is going to be log 2 upon 10 base 10, and next step I can write this is log 2 base 10 minus log 10 base 10. I know if I have something in the form of m upon n, that can be written as log m minus log n, right? So I just used that, and now this is going to be 0.3010 minus 1, and finally this is going to be minus 0.699 is the value. Now my value is negative. Till now we have used logarithms for some of the values, but we haven't seen any time the value coming negative. Remember my friends, in a number line, minus infinity, 0, 1 and infinity, in my first video I made it very clear. If you observe the graph which I have shown in the first video, between 0 and 1 the values will come negative. So this value is between 0 and 1. The answer I got is negative. Okay, exactly 1, the answer will be how much? 0, and above 1, till now we did all the problems above 1 and my answer was coming to be positive value. So logarithms is not defined for negative values. Between 0 and 1 the answers will be negative, exactly 1 it will be 0, above 1 it will be all positive values. That we know it, right? Now in this, the point to be noted my friend is characteristic is negative, mantissa is also negative. That means this is overall negative value, overall negative value. Now what we can do here, I just add plus 1 and minus 1 to this number. I'll add plus 1 and minus 1. Now 1 minus this is going to be 0.301 minus 1 is what you get, and that can be written as 1 bar 301. 1 bar 301. Now the difference is the same value can be written like this here. We all know by adding plus 1 and minus 1 the values will not change, right? So the same answer where it is completely negative, please understand it is completely negative, negative completely, right? But here you see characteristic is negative, mantissa is positive. Mantissa is positive. So what is the difference between this value and this value? Both are equal actually. There is a 1 bar. That 1 bar is nothing but we read it as minus 1 plus 0.3010. That means only characteristic is negative, mantissa is positive. Now you all must be getting a doubt. Why we have to write this when I got some value over here? When I got a final value over here. The advantage of writing this is, what is the value of the log 2 base 10 my friends? And what is the mantissa I got there? You can see the mantissa is 301 and here also the mantissa is 301. So because of 2 and here 0.2, the mantissa value will be same. I'll show you one more quick example here. We'll come back to this previous slide again. Suppose if my question is log 0.002 base 10. Okay, this can be written as log 2 upon, you can see how many decimals are there, 10 to the power of 4 base 10 I can write. Fair? And this is further can be written as log 2 base 10 minus log 10 to the power of 4 base 10 is what you get. And further this is log 2 base 10 minus 4 log 10 base 10 is what I get. And now let us get the values of all these here. Log 2 0.3010 minus 4 into 1, nothing but it's 4, right? So this is going to be further 4 minus this will be minus 3.699 is what I get. Now same thing by adding plus 1 and minus 1 here, by adding plus 1 and minus 1, minus 3 and minus 1 will become how much? Minus 4 can be written as 4 bar and 1 minus the rest will be 3010. See the same mantissa. What is log 2's mantissa here friends? 0.3010. Same mantissa will come. The advantage of writing this part instead of this, instead of the one which I got it here, this one, instead of getting this is this mantissa will match. Mantissa will be same. So to maintain the same mantissa, see the previous one also. Because of 2 here, the mantissa was 3010. I mean, this also is 3010. So mantissa will be same. The writing part here is mantissa will be same. So what is the difference between this and this, my friend? I wrote it very clearly. If I write like this, the entire value will be negative, and if I write like this, only characteristic value will be negative, but the mantissa value will be positive. Now, final point. What is the question? What can be the question here? Let us see the question here. Question can be asked like this. Can you see some zeros after decimal? Yes? Question will be, how many zeros are there followed by a decimal in the given number? In the given number, how many zeros will be there after decimal? In this case, the number of zeros after decimal are 3. 3. So what is my answer and how to get my answer? From the characteristic value. If you see, if the value is completely negative, straight away the characteristic value will be the answer. Number of zeros are 3. Here the characteristic value is also 3. If the entire value is negative, then the characteristic value itself is the answer. But if you get like this, then my characteristic value minus 1, that is number of zeros will be one short of the characteristic value. That's the difference. One short of the number of characteristic value. Okay, sir, all of you? So characteristic value is 4. So you will have 3 zeros. If the characteristic value is 5, I will get 4 zeros. If the characteristic value is 6, I will get 5 zeros there. Is that clear, all of you? Now, for example, I'll quickly run some examples here. Suppose if we have 0.00000002. How many zeros are there after decimal? We have total 6. So this will be 7 bar 3010 is the answer. That's an advantage of writing that +1 -1 kind of an answer. You see, I got the value very straight away. Number of zeros will be one short of the characteristic value. That logic I need to apply. Fair enough? So let us do one question, all of you. Question is, find the number of zeros number of zeros after the decimal, and the question is 3/4 whole to the power of 10. 3/4 whole to the power of 10. Now to find the value, characteristic value, I should find log of the number. This will be 10 log 3/4. This will be 10 log 3 minus log 4. And this will be 10 into log 3 value, I'll get it, log 3 minus, can I write this as 2 log 2? Fair? This is 10 into, this is 0.4771 minus 2 into 0.301, I'll get. And now the values will be 10 into, if I multiply them, what do you get? 0.4771 minus, if I multiply 206.0. Now subtract here. So what do you say here? This minus this will be how much? In fact, I should do the reverse part. 1 or 2 minus this will be equal to say around 29, 31. This will be 31, and then 0.6 minus this will be equal to 0.5. So 0.1 into, and that is minus sign over here, into 10. So if you multiply with 10, this will be 1 point, minus 1.31 is what I get here. And the same thing when I convert by writing +1 and -1. +1 and -1, the same thing will be, say -1 minus 1 is -2. 1 minus this will be equal to something around 69 is what I get. So here I got 2.69, minus 2.69 as a value. So this is minus 2.69 as a value I got. And the characteristic value is how much here? 2. I got 2 of the values here. One can be this value and one can be this. Suppose you are looking at this, then the characteristic value will be 1 more than the number of zeros. So this will have only 1 zero after decimal. This will have only 1 zero after the decimal. So answer, whatever I get here for this, will have only 1 zero after the decimal. So that is how we can find out the number of zeros after the decimal. Okay, all of you? So this is what you have in logarithms as application of logarithms. Please do practice on this and find more and more questions of a similar type. Okay, thank you all.